Hey everyone, back here with the HTS guys. Got Will and Mo back. They came back with a bunch of questions that they were getting, that people were asking about the Sharc systems, and I'll leave it to them, to kind of go through what they've been getting, and we'll put it into a nice video so that people can understand the questions that are being asked and also the answers. But I'll throw it to you guys.
Great. Yeah, thanks for having us again. Today we get to put Lynn's feet to the fire a little bit and have him explain to us some of the technical aspects of the Sharc and Piranha product. So the first question that I would have for you, Lynn, is there anything in the plumbing code that engineers should be looking out for and keeping an eye out for? As you know, this is new, so that's a popular question that we get.
Yeah. There's a few references in the plumbing code, but everywhere we've ever installed around the world, it's dealt with as a wet well. So if you go to the wet well requirements, and a lot of buildings have them, most cities now are requiring tanks to sort of time out the sewer into the infrastructure. So it's basically handled as a wet well. And what we've done too, Mo, is we have about 30 different connections that we can give you that are pre-engineered for your engineers to select from, how they connect to the various different types of sewer lines. So Jody will have that in your manual, I'm sure, or Brock. So yeah, we've run into a number of questions, but basically the sewer infrastructure people have embraced the use of Sharc, so never been a problem.
I guess one of the next ones we want to talk about was freeze protection guidelines, and maybe not necessarily freeze protection, but how low can we go with the temperature before we start really impacting the system? We've heard concerns back from municipalities, from owners, that if we drop the temperature of the wastewater too much, we can get poor wastewater treatment, that it requires some temperature to activate the biological process.
Yeah, and that temperature is right around 11 degrees C. So if you have a Sharc or a Piranha system in, we tend to only lower the temperature leaving the building by a couple degrees. So each building, or even the biggest one we've ever done here, Will, is the False Creek Energy Center, and they heat 5 million square feet of apartments with the heat they take out of the line, and they still can't measure the temperature difference.
Oh, really?
There's so much flow that unless we're overwhelmingly successful, you just can't even notice it.
Okay. And actually, can you talk a bit about that False Creek? Because that one comes up all the time as an example. Can you talk a bit about how that was used, scale, what kind of wastewater they're treating, coming with?
Yeah, that is 3.5 megawatts right now of recovered heat. So they've got a big screw chiller in there that removes 3.5 megawatts from the 100 million gallons of sewage that flows through there in a day. Mm-hmm. And when they did the study and answered the same question you asked, they hired Kerwood Lydell or somebody to do a study on it. And they determined they could not only expand that to 4 times the size of it is now, but they could do another 700 high rises before you could detect the temperature difference.
Oh, really?
There's so much energy in that 100 million gallons that you can't measure it. But I was there this week actually working with the service guys on it, because I like to keep in touch with what's going on. And the temperature coming in was 78 degrees Fahrenheit or 25 degrees Celsius. And it's just so many people, use hot water. But another rule of thumb is if you have a Piranha system, for instance, you can't take the temperature of the water leaving the building lower than the incoming temperature. So what they don't want you to do is use the incoming water as an energy source. So if it comes in at 6 degrees, it has to leave at 7 degrees.
Is that something that's dynamic for you? Like, is the Piranha measuring the incoming domestic cold water temperature? Or is that just a the lowest temperature you'd expect over a year?
That's just the lowest. We've never seen it below 17. Because the thing about the piranha is as you're using the energy, the hot water's coming back into the storage tank. So it just sort of displaces what's being used. So the lowest we've ever seen leave the building is 17 degrees C.
I'm more talking on the inlet side, like you're talking about, like 17 is quite high, but is there any requirement to look at the incoming domestic cold water feed from the city and compare that temperature versus what you're discharging from the piranha system?
Yeah, that's where they say you can't be lower than that incoming temperature. Yeah. But we don't monitor it or anything because we've never been anywhere near it. But we do monitor those temperatures all the time on the piranha control system. So you could take your smartphone, Will, and look up that piranha system and see every temperature in the system.
Actually, that's a great question that we do want to talk about later. Is can we get a link or put on under the YouTube video a link to a live stream that someone can go talk about that we can show in a presentation?
Yeah, you sure can. I'll have Matt set that up for you. Every system we do has a live feed from it. So we were just looking at Falls Creek, for instance. So we know that there's 2,400 gallons a minute coming into the Sharc at 25 degrees or 26 degrees. We know there's 3.4 pounds pressure drop through the Sharc. And, we know how much goes out of the bottom of the Sharc, how much goes through it. And then the temperature goes back in. So yeah, we'll get you a live feed for that, and you can watch a system.
Well, I want to circle back and touch on another aspect of the freeze protection. With the holding tank itself, do you have installations where people maybe put it outside, or they put the tank maybe in the ground and it becomes a holding tank? Do you have to worry at all about freeze protection, or is it just because there's always incoming water that you don't necessarily worry about it?
Yeah, it's never come up, Mo, and because they're inside or they're buried, so we would bury them below frost level, or you should move to Vancouver where it never gets that cold. But
we all wish, yeah.
They're inside the building all the time, so you wouldn't be exposed to freezing temperatures.
Right. I was thinking about retrofit applications where you may need to put a tank outdoors, but I guess we haven't run into that yet.
Yeah, I'm sure, there's probably code in Toronto that if you got a tank out there, you got to have some sort of protection, but right. We've never seen one outside.
Why is Sharc better than Noventa? So maybe I'll let you explain that product and talk about, the essential differences between the two.
Yeah. And Noventa Energy there in Toronto, Dennis reps a company called Huber. And Huber's a tremendous company out of Germany, and they supply a large portion of the equipment in a waste treatment plant. They've got bar screens, they've got all kinds of different things for sewage treatment plants. They can adapt one of their systems to do sewage heat recovery. But the largest one they've ever done is like 0.5 megawatt, I think 600 kilowatts. So to give you an example, on Denver, we got the job there using 2 Sharcs and 2 heat exchangers. 4 Sharcs and 2 heat exchangers. Noventa did the same job using 2 of their big screening systems and 24 heat exchangers. So you would have to try to balance the 40,000 gallons a minute through 24 heat exchangers. So there's some piping issues and stuff. So we tend to be less expensive and more efficient and much more scalable. So, if you're putting in 0.5 megawatt per heat exchanger and you're going to do, like in Washington, D.C.'s 30 megawatts, you'd have to have 50,000 square feet for heat exchangers. So we have 2 large plate and frame heat exchangers, and sort of makes it easier and feeds into your next question there about the heat exchanger performance and the fouling factor. And with our heat exchangers in 10 years of operation, Mo, we've never had to clean a heat exchanger. And that's hard to believe on 25 systems. Like we constantly use the back flush, which I see was another question. So every 10 minutes, the flow reverses and goes the other direction. So the beauty of the Sharc system is it screens down to 2 millimeter in size, and we use an 8 to 10 millimeter gap on the heat exchanger. And because I think we're drawing off of the bottom of the pipe, what we always worried about was grease and all that sort of thing, but we never see it. In 10 years, we've never cleaned a heat exchanger, never taken one apart. So we think it's because we draw from, lower in the tank and whatever, and the grease floats across the top, but never had any issues. And we monitor the temperature difference across the heat exchanger to 1/10 of a degree. And we've never seen one change more than 2/10 of a degree in 10 years. So we're pretty happy with that. And those reversing valves just automatically switch back and forth every 10 minutes. There's no shutdown. It's all done live while it's flowing. So it's worked very well.
Yeah, so that would be the backflush would be the key that you don't necessarily see on the commercial HVAC side for heating and cooling, right? Where we don't necessarily do that. And then obviously you have your incinerator, which essentially takes care of all of that. So that's good to hear.
Yeah, and I think the velocity of the flow is quite high. So we work on a pretty narrow threshold. Like if your incoming sewer is 72 degrees, we can give you about 69 degrees on the outlet. So pretty close threshold too. So we get really good performance out of those heat exchangers. And the big difference too is that we don't deal with the effluent. We deal with the influent. So we don't have biofouling and that sort of thing. And you're gonna hear that term quite a bit, probably biofouling. But that's once the bacteria has been introduced to eat the solids at the plant and it leaves the plant, the bacteria grows on and it'll foul a heat exchanger within days. We take it before that action starts, and we've never had an issue.
Yeah, that's great. And actually, on that topic of the heat exchangers, though, so it's good to understand about the backflush process. So we're not losing any performance. There's no derate because we're doing a backflush. It's just reversing every 10 minutes. So we're a continuous operation. Yeah. So the question is on the other side of the heat exchanger, let's say the HVAC side. So can you talk a bit about what that is? Is it still an 8 millimeter gap in the plates there? And have you ever gone, instead of just producing, say, condenser water, have you ever gone direct DX where you have refrigerant directly in there?
Well, we do that on the Piranha. That's a DX condenser, but not on the big plate and frames. We really haven't even looked at it, but nobody ever asked the question until I saw it here. So I'm going to talk to SWEP, our heat exchanger suppliers, and see if that's possible. Because I think what you'd need is sort of like a sealed plate and then a break apart plate. So I'm not sure how we could do it, but I'm gonna ask the question for you.
Yeah, because my concept was if we could use R134A, which has a max pressure of 150 psi in a mag bearing chiller, so there's no oil anywhere, that might be a reasonable application for the machine. And then we could avoid a whole nother water loop.
It'd be nice because you could gain quite a bit of efficiency too.
Absolutely.
Yeah. Okay, I will check for you. We've when you mentioned 134A too, we've switched the Piranhas to 513. So 60% reduction in the global warming potential number, and virtually the same operating pressures and temperatures as 134A.
Yeah, actually, that kind of leads into another question. So I guess the first one is about your choice. So, it's great to be moving ahead with low GWP refrigerants, but what about availability of compressors, availability of refrigerants in the marketplace? Because we're not seeing a lot of products yet use that refrigerant.
Yeah, well, we use a Danfoss compressor, and it's approved. The same compressor 134A is a drop-in for 513. Mm-hmm. So our compressors are approved, the same oil, same everything. Don't change the expansion valve, nothing. So it's been a really easy one, and it's warranty approved with Danfoss.
And then I guess the last question on that, for respect to Mo. So of course you made a choice there in the Piranha to reduce the embodied carbon of the machine. Anything about reducing the embodied carbon of concrete tanks or the rest of the Sharc system or Piranha system to improve the overall global warming impact of the system?
That question kind of caught me unprepared because I don't even know how to do that well, but I've got the team working on it.
Yeah.
We're going to try to develop a number for you on what that is. And so, we seldom use a concrete tank now. We always use a fiberglass one. So I'm going to find out for you.
Yeah, and it's not something that's come up yet, but as we move forward with building design, like the Canadian Green Building Council zero carbon standard now requires you to look at the embodied carbon of the facility. And so anything we can do to reduce the embodied carbon as well is all part of the whole picture. It's not just about reducing natural gas, but reducing the embodied carbon as well.
I'll find out. That's really kind of the first time I'd ever heard about it. So, I mean, not really, but
there's a lot of first-time questions here, right?
Yeah, nobody'd ever asked that before, but I'll find out for you.
Can you tell us about where you manufacture your products?
Yeah, so we manufacture, as of today, everything right here in Port Coquitlam, and by and large, most of the products come from the U.S. So we manufacture here, but we do have plans to open a plant in the U.S. in the next year for sure. We will then be able to get much better access to U.S. certification, UL, ULC, CE, and all that. So, but right now they're all built here. But that probably will change as our market. We got some HTS guys in Texas doing a great job, in Boston and stuff. So New York. So we want to be ahead of that game. But right now, right here in good old Port Coquitlam, which I hope you'll visit soon when the COVID's over, I think you will see the new refrigerant's going to be pretty popular. Part of our EPRI program that we were successful at there in the Noventa Energy is to test the results of the new refrigerant. And we've been testing it here, and we know it's almost identical, slightly better actually than 134A, but only 1% or 2%. So we're very excited about confirming that too with EPRI. We put all the meters and stuff in there this week, and we have 2 weeks to measure business as usual. And then in 2 weeks, we start running the new Piranha HC in there. So that's a huge day for us.
The tank and system maintenance. So I'm not sure if we went over this before, but can you just go over again? You're talking about, that's always a question that comes up, wastewater, it's dirty, needs cleaning. The tank, the Sharc system, what does an owner expect to do for maintenance on this type of system?
Yeah, the great thing, Will, is that it does require maintenance, but when you do the maintenance, it requires, planned maintenance, but not a great deal of parts and pieces. If you don't do the maintenance, you're going to have trouble. So we always like to sell a maintenance contract with them. So basically there's 4 services a year, and one service with the Sharc is we replace all the moving parts once a year. So the screen, the auger, the brushes, everything are replaced once a year. So you basically have a brand new Sharc once a year. And then the other 3 times are check oil levels, check amperages, all that. And that's even been automated now. So everything is recorded. So maintenance is very little. You pump the tank out once a year using the pump that's, part of the system. and then we basically flush it out. And so the maintenance once a year is about half a day. The other 3 maintenances are about 2 hours. So very little, and because we built it so robust, and we virtually replace every moving part once a year, we just don't have a tremendous amount of maintenance. I mean, I was down at Falls Creek helping Matt with the maintenance this week just to keep in touch with what's going on. And in 2 hours, we had all of the parts changed on the biggest Sharc we make.
And what kind of cost can you expect? So 2 hours, we know what that costs in the labor rate, but what kind of cost can we expect for all the parts on, say the Sharc system there?
Yeah, to give you an idea there, it's, let's use Washington, D.C. They're the D.C. headquarters building. So there's 4 services a year for a total of $12,000 a year on a system that's cost about $500,000.
That's all in parts and labor service? Maintenance.
Yep, and that's a planned maintenance agreement they sign with HTS, or in that case, it was Critical Systems down there. But yeah,
that sounds about like a chiller contract.
Yeah, and because it's all monitored, we actually have the predictive built into that. So if the system sees something that's outside of normal, before it shuts it down, the system itself emails the service guy and tells them to go check whatever the alert is. So pretty intelligent machine.
Yeah, wave of the future. Nice.
Yeah, not as smart as those HTS guys, but it's getting close.
Right.
Yeah, so we'll get. I'll get back to you with those answers there on the DX and on the embedded carbon.
Yeah.
And
also, I was thinking on the DX too. Ask about 1233ZE. That's another new low pressure refrigerant that's becoming very popular.
Okay, I will, sir. And the pressures are about the same as 134A, you said, so.
No, it's a low pressure, so it's around 20 psi.
Oh,
it's very low pressure.
So kind of like R11 or something.
Something like that, yeah.
Okay, perfect. And one thing, the number one question I get in every system I ever sold is if I put the system in, do I have to smell sewage in my building? And the answer is no, of course, because it's completely sealed. And then people also think that you're pumping sewage water throughout the building, and that's not the case. It's in the mechanical room only. So those were the 2 questions that always used to get asked. But now that we have so many of them in, it doesn't seem to be much of a problem. But we're anxious to get you folks up and running down there, and we know that we're going to have some fantastic results in Ontario and beyond.
Yeah, we hope so as well. Lots of interest here. So.
Great, thanks, guys. Thanks, Jason.
Perfect.
Yeah, thank you.
Awesome, guys. Thanks for hopping on.